Star Trek notoriously plays with hypothetical ideas in physics, especially when it comes to traversing intergalactic distances. Warp drive, wormhole, can you tell us about what Star Trek gets right and wrong?
Yeah, what's amazing about those things, and when I wrote the book, what surprised me is those are among the most sort of fantastical things in Star Trek, the kind of things that seem the farthest out. And what is amazing is that they're not impossible. At least we can't say that they're impossible. I mean, the motivation is clear. Traveling at the speed of light doesn't get you very far. The distance between here and the center of the galaxy is maybe 30,000 light years. So even traveling at the speed of light, it takes you 30,000 years to get to the center of the galaxy. That does not make for an exciting episode. And so they had to figure some way to go faster than light. But the problem is that you all learn in school in kindergarten that you can't travel faster than the speed of light. That's what Einstein says, right? But you have to be like a lawyer and parse a little more carefully. You can't travel through space faster than the speed of light, but space can do whatever the heck it wants. And so in fact, had Einstein been around, he would have thought of something that he would have called warp drive. And warp drive, of course, is a way to go faster than light. And the writers, of course, if you read how it's supposed to happen, of course, it's nonsense. But in fact, in principle, you might be able to do it. In fact, given the laws of general relativity, you, in principle, could, because what general relativity tells us is that space is dynamical. It can expand, it can contract in the presence of it. It can warp. And in fact, of course, I brought a few warp drives here, as you can see. We actually experimented beforehand with several balloons, but happily, the World Science Festival was able to provide another thing which works better.
Safe science.
So, yeah, safe science. In fact, always perform safe science on stage. But this is, you won't be able to see all the details. This is kind of an impressionistic example, but it actually is exactly what warp drive would be if you could make a warp drive. So what I've done here is you can sort of see the sun and the moon and Saturn, just to give you the local environment. And this is a beautiful rendition of the USS Enterprise.
It is beautiful.
You would recognize that. And so I've taped it to this balloon. And here's a star system here, and here's another star system here. And I want to show you how the Enterprise can move away from this star system and towards this star system without ever moving with respect to its local surroundings. And you do that simply by expanding space behind the spacecraft and contracting in front. So I'm just going to stand behind you. That's why I want to stand behind you.
Why are you doing it near me?
No. There we go. There we go. If I'd used the balloon, it would have popped. But what you can see is I squished the balloon behind it, and these stars get dragged away, but the Enterprise, of course, never moves with respect to its local surroundings. So this is possible in principle in the real universe. The question is it possible in practice? And the answer is we don't know. It's an open question, because in order to make space expand, you have to fill it up with a very special kind of energy, something called negative energy, which sounds like something that was invented by a physicist in a room without windows for too long, which is true, in fact. But it actually exists. Due to the laws of quantum mechanics, negative energy configurations can exist for very short times. But what we don't know, and really this is the open question, is could you make enough negative energy to actually do anything like this? And we just don't know the answer. People like me actually get paid to worry about that. But the answer is if you could make negative energy configurations in principle, you could make a warp drive.